After we solve the bottom two layers, except for this corner and this edge, there are 5 edges left to solve. 4 at the top, 1 at the slot. In this phase, because the top is not solved yet, we can turn the top layer whatever we like. So think of this top layer as a carousel. There are 4 seats, 4 horses. You need to make 4 yellow edges on board to their correct positions, with yellow facing up. You'd also have this position as a waiting area. An edge can stay here and enters the carousel like this or this. But remember, yellow should be facing up. Now there's still no algorithm in this phase. Instead, there are only rule of thumbs. So let's start with an example. We always start with the edge at the waiting area. We want to make this on board to its correct position at the top at the carousel. But what do you mean by correct? We have to have an anchor. There are 4 edges at the top. So let's pick an edge with yellow facing up as an anchor. For example, maybe this one, this red, yellow one, yellow facing up. So we treat it as an anchor. This side color, we align it with the center color. So now, actually this piece is solved. So now we have an anchor. This green edge should go to this position because this is the green center. Now we know the destination. How should we move this edge to that position? The answer is very simple. It's similar to the white cross. Imagine that if we want to onboard this edge, we rotate like this because what the white is facing, the yellow is facing up. So we move the position to the entrance. We rotate to move it to the top. Now this green edge is solved. But we break this part, so we have to recover it. And when we recover it, we can bring down an unsolved edge. For example, this yellow edge, orange yellow edge. So we move this edge to this position and then recover. And you see that when we recover this, this actually goes down. So we solve one edge by moving the edge up, and we bring down an unsolved edge. One up, one down. So now this edge is solved. We know that by aligning the center, you see that the side and the center connect. This is connected as well. Now again, we want to onboard this orange-yellow edge to its correct position. Do we go like this? No, because yellow is not facing up. So this time we have to rotate like this. You see that this is the position this orange edge has to go because this is the orange center. So we move this position to here so that we can onboard it. Now we have to bring down the other edge. So we rotate like this, we bring this edge down. Till now we've been following the same rule of thumb. That is, we bring up the edge at the waiting area to its correct position. So we solve that edge. And then we bring down another wrong edge down to the waiting area. So this back and forth thing, we have more and more solved edges at the top. But if we keep doing this, we will get into trouble. Here's case number 1. You see that this is the blue edge, so the position is here. So we onboard like this, and now you see there are 4 yellow edges. But this part is broken, so we have to recover it. But the question is, all 4 edges are correct, so we don't know which one to bring down. So we have to use some imagination. For this case, let's say this last edge is a boss. He bullies people. So instead of going to the correct position by squeezing out this non-yellow edge out, he likes to kick people. So turn this yellow edge to here, and then he goes up and declares that now I am the correct. all of you are wrong. I am the anchor. So now all these three edges are wrong now. And here's the correct one. And what should we do? Because we have to recover this, so eventually this has to go back. If it goes back like this, it goes to this position. So this is the red edge, this is the blue edge. Where should this red edge goes? Blue is here, red is here. So the red has to go to this position. So now we bring this position to here. So when we recover this, it's in a relatively correct position now. So because red is here, if we align it to the center, again we know that this is the position for green edge. So we have the green edge here. So let's move this position to here so that it can go up. And then because we kick this orange edge out, so when it comes back, it has to go to the correct position, which is here, because orange is at the right side of the green. So it would move like this, we move the position here, and when it recovers, it goes to this position. And finally, when we align the sides to the centers, you see that actually all four edges are solved. There are two tricks in this case. First, correct is just a relative term. You thought that these three edges are at the correct positions? No. When the fourth yellow edge is at the waiting area, it actually becomes the anchor. So it is correct, all the others are wrong. Second, when the fourth edge is at the waiting area and it kicks out the edge, we no longer cares about which edge to bring down to the waiting area. It's something like this is actually something that we need to focus. We need to think about when it comes back, which position it goes to. So for example, this red, this blue, red is at the right side of the blue. So we move this position and brings it back. We don't even care about, actually we brings down the green edge to the waiting area. No, we focus on the edge that we kicks out and focus on bringing it back to the correct position. Trouble case number 2. There are 3 correct edges at the top, and the fourth yellow edge is also at the top, so that means it's in a correct position. Just that the orientation is wrong. We have to flip this edge. In order to flip an edge, we need to bring it down to the waiting area so that we can bring it up in a correct direction. But how do we bring this edge down to here? We have to kick out a correct edge. So now this position, when it recovers back, is in the working area. So we bring this blue-yellow edge to this position so that when it recovers back, it goes down to the waiting area. Furthermore, because we kick out this correct edge and we turn the top, so when this recovers back, it's actually in the wrong position. You might say that, no, it's orange, right? No, because when we align these two are in the correct position, and this is not. So now we focus on solving this blue-yellow edge. So because this is blue and the position is here, so it has to go up like this. And then we focus on the edge that we kick out, just like the case number 1. So when it comes back, it goes back to this position. And now we realign again. You will see that all 4 edges, including this edge, are solved. There are a couple of edge cases I didn't mention because they are very easy. For example, we say that we always start with the edge at the waiting area, but what if this is not yellow? It's very simple. We just bring it up to any position, and the point is to bring down a unsolved yellow edge to the waiting area. The second thing is we say that we need to find an anchor for the correct position. But what if the 4 edges at the top, they don't have yellow facing up? Then it's simple. This will be our first anchor. We just unboard it in the correct position and then bring down some yellow edge. And this is blue, so we align it with the center. Now this is our anchor. Although I mentioned several cases in this phase, my advice for you is don't memorize them. It will be complicated. Try to play around to gain the concepts.